So again, we're on lesson 8.5, the last of the lessons in chapter 8. And this is the surface area of a cone. And today's date is 5/18. So let's just kind of talk about what we were paying attention to in a cone when we were dealing with volume. And these were the key ingredients that we needed. We needed to know the radius of the cone, and we needed to know the height of the cone. And with those two pieces of information, I could figure out the volume. The formula for the volume of a cone was very similar to that of a cylinder, with the exception of, since the cone comes to a point, it's skinnier than what a cylinder would look like, so we would need to have less volume in a cone than a cylinder, and so the fraction was 1/3, okay? Now, having said all that, when I open this up and I make a net, big differences that you see is my net only produces one circle, and then we have a wedge, okay? So we've got a circle. Now I can figure out the area of a circle, pi r squared. But then I have a wedge. Come on, you. And how on earth do we deal with that? Okay. So what we're going to do is talk about something called lateral area. So that's the wedge. Now, we're going to introduce a new dimension, and you guys saw that yesterday on the performance task. Does anyone remember in the glass that had the bowl that was an inverted cone? They gave us two dimensions. They gave us across the circle was 6, and then on the side it was 6. Does anyone remember what they called that on the side part? It wasn't called height. Remember, we had to calculate that. No, that's the one that we had to calculate for question 1. Remember, it has to look just like this red one. But now we're talking about something on the edge. Do you remember what that was called? It was called slant height. So we have a new dimension, and this is the slant height. The slant height is always presented like a cursive L. This is your slant height. This is your slant height. So let's kind of talk about slant height. Now this is only part of cones. And the slant height is, let's see if I have a good definition for it. Not really. There's not really a good definition for slant height. So we're going to call slant height the lateral height, or the lateral length. I think that's a better word. The lateral length of a cone. And what does lateral mean? What does lateral mean? Where are your lats?
On the side.
They're on the sides. Okay, so when we talk about lateral length, we're talking about the side length. Okay, so that's slant height. It uses the letter L, cursive lowercase l, as its symbol. Okay, so you'll see that. So in order for us to figure out the wedge, we're going to figure out the lateral area. Okay, let me try this again. I'm experimenting with my Apple Pencil here, and so I don't know if the problem is the pencil or the program. So how do we figure out the lateral area when we have a wedge? Okay. Well, we're going to use a formula. The formula asks us to take the radius, multiply it with pi, and multiply it with the slant height. So this is the hard part. There's no easy way of coming up with this. We just have to memorize it. This is when we use flashcards, right? Because that's going to help. All right? So that's it. We know how to figure out the circle. It's that wedge that we have a problem with, that lateral area. So we have to memorize this. So let's just do a couple practice problems with just lateral area. Everybody good here? Okay. So examples are going to be find the lateral area. And by the way, what is the abbreviation for lateral area? LA. Okay, so find the lateral area of the cone. And then round to nearest tenth. Okay, so let's do one. We have a cone. We're going to be given a couple pieces of information. We're going to be told this is 5 millimeters, and then they're just going to say 13 millimeters. So if you recall when we were doing volume, they would draw a line to what it linked to. For us, when they write on the outside edge of our cone, they're describing slant height, okay? So we identify our two key pieces of information. We're given a radius of 5 millimeters, and we're given a slant height of 13 millimeters. Now this is area. All of these are area, so what kind of label am I supposed to get for area? I'm supposed to get a squared. So we write down the formula, and we write it down on our homework tonight because we want to get this embedded in our brain. But again, big suggestion, make your flashcards. And we're going to take pi times the radius, which is 5, times, oops, sorry, I'm supposed to put a number there, 13, which is our lateral area. And we multiply 5 times 13 is 65. Pi. And then this is when I pull out my calculator and I do 65 times 3.14159, and I get 204.20, come on you, 335, and then I'm going to round to the nearest tenth. 0 is not enough to round the 2 up, so my final answer is approximately 204.2, and then the label would be squared millimeters. Okay? So I'm going to have you guys try one on your own, and I'm going to share with you just information. We have a cone with radius let's see, 4 inches, and slant height sorry, come on you, of 9.5 inches. So what I'm going to ask is that you guys take this to the pi version, because you don't have calculators on you right now, okay? So solve this for lateral area and leave it as the pi form. So in the last question, you would stop at 65 pi, okay? And we'll go the next step together. So if I take, for the lateral area, and I multiply pi times the radius, which is 4, times the height, which is 9.5, I get 38 pi. Because 4 times 5 is 20, and then I carry the 2. 4 times 9 is 36, plus 2 is 38. So now I multiply 38.3.14159, and I get an answer of approximately 119.38042. Then I need to round to the nearest tenth. The 8 is definitely large enough to boost up the 3 to a 4. And so my final answer would be approximately 119.4, and now I put in my label, square inches. Okay? All right, so how many parts does my cone have?
2.
2. And the area of the wedge, the cone side, is what? What's the formula for that? Pi RL, pi times radius times slant height. So now what we have to do is add on, if I want to figure out the surface area of the whole thing, the area of the second piece. What's the second piece? What shape is the second piece? It's a circle, and the formula for the area of a circle is pi r squared. So the formula for surface area, and by the way, what's the abbreviation for surface area? SA, and this is of a cone, is pi RL, that's the lateral area, plus the area of the base, which is the circle, pi r squared. Okay? So this is the formula that you have to memorize. But if you got down the hard part, the lateral area, and you realize there's just one more circle, then, and you know the formula for the area of a circle, you can put it together. So this isn't that hard to memorize this, okay? The trick comes in is, what if they don't give you the slant height and they give you other pieces of information? Now, I'm just going to casually look and see if they're evil. No, they're not evil at all. So the question we did on the task from yesterday, the first question we worked on together, where they gave us the slant height and they gave us a radius, and we had to figure out the height of the cone. They could reverse it and give us the height of the cone and the radius, and we have to calculate the slant height. That would still be Pythagorean theorem. But this time we'd be calculating the hypotenuse part, the C part. What I'm seeing on the homework, they're not making you do that. So we're just like, let's just work on this formula, get it down, and practice it. Okay? All right, so let's go ahead and do a couple of examples of these. Oops, sorry, let's color back to black. So examples would be find the surface area of each cone. So sometimes they're going to draw a picture of it. They're going to add in important information. This is 6 inches. And even though it looks like they're doing this, and they say 6.2 inches, again, what they're referring to is the slant height, okay? So because I'm trying to memorize my formula, I'm going to write it out. SA for surface area equals the lateral area, which is that pi RL, plus the area of the circle, pi r squared. And then I just start putting numbers in. So I have pi times the radius of 6 times the slant height of 6.2. I'm going to add to that pi times the radius 6 squared. And then I just start doing math. Well, 6 times 6.2, I get 12. 36 and 1 is 37. There's one digit after the decimal point, and then the pi. Over here, 6 squared is 36. And I have pi. Okay? Is there an issue? No? So that's going to give me, when I add them, let's see, 6 and 7 is 13, carry the 1. And then I've got 6, 3 and 3 is 6 plus 1 is 7. So I get 73.2 pi. So now what I'm going to do is multiply that guy, 73.2, by pi 3.14159. And I get 229.9643888. So this one I'm going to round to the nearest tenth. Oops, sorry. And what I notice is the 6 is going to bump the 9 up to a 10, but I got to kick that tens digit over to the next column. So for my final answer, I get, oh, and that gives me a 10, and that kicks over. So I end up with 230.0, and the label is square inches. Okay, let's do one more. Oh, did I go too fast? Everybody get that? Good? Yeah. Okay. So let's have you guys try this one. Let's say we have a radius of 4.5 millimeters and a slant height of 20 millimeters. Go ahead and figure out to the pi answer what the surface area would be. So what you need to do is multiply 4.5 times 20, and that's where the 90 pi comes from. So Dylan, you stopped there with the lateral area. The directions asked us for surface area because we're underneath that new set of directions. Then 4.5 squared was 20.25 pi. And we add those together, we get 110.25 pi. So that's where Susie was. So must have been just a slight calculation error on your part? Okay. Yeah, and that's, again, on a test, you're going to be able to use the calculator. So we're going to take 110.25 and multiply it by 3.14159. And notice how I'm going from equals to approximately equal to. And I get 346 point, and then it's 3602975. And then I round to the nearest tenth. And so that's going to give me a final answer of 346. 6 is going to round that 3 up to a 4. And then label would be squared millimeters. So, oops. Try that again. Okay? Now, one more idea. If you were given a word problem, what things do you think they could test you on that is basically asking you for the surface area or lateral area of a cone? So what are some things you can think of in the real world that would be cones that you might need to do some stuff on? Okay, what are some things you could think of? Oh, come on, people. You know what cones look like.
Never seen
Okay? Let's say you're being asked to make a party hat and you need to figure out how much material you need to purchase to make the party hat. Okay? Good. Now that would be lateral area, right? Because if you had the circle there, you couldn't get it in your head. It was perched on top. Okay? Sophie?
one.
Ice cream cone. So it might be the actual cone itself. Oh, you're being a pain, aren't you? And again, it would just be how much of, like, let's say the waffle that you need to have in order to create this ice cream cone. Okay. What else can you think of that you've come across that would be cone shaped? Traffic cone. So again, trying to figure out material for that. So the one I'm not hearing, which makes my daughter would come up with it like this because she is the ultimate fort builder, teepee. Okay, so those are all things that you may see in word problems that indicate, oh, they're asking me for surface area of a cone. Okay, all right.